Hello everyone, welcome to my channel TechQuest Learning Point. I hope you all are doing great. I am Bashar. In my previous tutorial in this series of Azure Fundamental, I already discussed on the topics of core architectural components of Azure. Today I am going to start a discussion on the topic of Azure Compute and Networking Services. In this tutorial, you will be introduced to the compute and networking services of Azure. You will learn about three of the compute options such as virtual machines, containers, and Azure functions. You will also learn about some of the networking features such as Azure Virtual Networks, Azure DNS, and Azure ExpressRoute. I can assure you all that this tutorial will make sense to you about Azure Fundamentals. This ultimate target of this tutorial is to make you prepare for the exam AZ900 Microsoft Azure Fundamentals. If anyone want to be the Microsoft Certified Azure Fundamentals, this tutorial will be the right choice for them to make clear the exam AZ900 Microsoft Azure Fundamentals. This tutorial is derived from the Microsoft Learning Path for Azure Fundamentals exam, so anyone can rely on this tutorial to take the preparation for the exam AZ900 Azure Fundamentals. Let's see the contents of this tutorial at a glance. This tutorial focuses on some of the computer services and networking services available within Azure. It covers the topics including comparison of compute types, virtual machine scale sets, virtual machine availability sets, Azure Virtual Desktop, resources required for Azure virtual machines, Azure Web Apps, containers, virtual machines, Azure Virtual Networks, Azure Virtual Subnets, peerings, Azure DNS, VPN Gateway, ExpressRoute, and public and private endpoints. The exam AZ900 Microsoft Azure Fundamentals includes three knowledge domain areas such as number 1, describe cloud concepts, number 2, describe Azure architecture and services, and number 3, describe Azure management and governance. This tutorial is the 10th episode of the Azure Fundamental series and it's a part of 3 knowledge domain. Azure Virtual Machines. By means of virtual machine service, you can create and use VMs in the cloud. VMs provide infrastructure as a service IaaS in the form of a virtualized server and can be used in many ways. Just like a physical computer, you can customize all of the software running on your VM. When you want to total control over the operating system OS or the ability to run custom software or to use custom hosting configurations in your Azure cloud computing, in this case VMs are an ideal choice. In Azure VM, it's possible to virtualize a computer without having to buy and maintain the physical hardware. Therefore, you can create a computer virtually without any physical hardware in Azure Cloud Computing environment. After creating a virtual computer, you need to configure, update, and maintain the software that runs on it as an IaaS offering. In order to provision VMs rapidly, you can use an image of a previously deployed VMs. It's possible to create and provision a VM in minutes when you select a pre-configured VM image. An image is a template used to create a VM and many already include an OS and other software like development tools or web hosting environments. Scale VMs in Azure. In order to scale up or down the computing of the VM, you need to group VMs together. In this way, you can group VMs together to provide high availability, scalability, and redundancy. Azure can also manage the grouping of VMs for you with features such as scale sets and availability sets. Virtual machine scale sets. In Azure, virtual machine scale sets is defined as a feature or tool where you can create and manage a group of identical load balanced VMs. If you want to create multiple VMs with the same purpose, it is essential to ensure that all VMs are configured identically with the same network routing parameters to ensure efficiency. It's also essential to monitor the utilization of determine if you want to increase or decrease the number of VMs. Instead of above manual tasks, most of that work can be done automatically by using virtual machine scale sets. It's possible to centrally manage, configure, and update a large number of VMs in minutes by using scale sets. The number of VM instances can automatically increase or decrease in response to demand, or you can set it to scale based on a defined schedule. Virtual machine scale sets also automatically deploy a load balancer to make sure that your resources are being used efficiently. With virtual machine scale sets, you can build large-scale services for areas such as compute, big data, and container workloads. Virtual machine availability sets. Virtual machine availability sets is defined as a tool by which you can build a more resilient, high availability and environment. Availability sets are designed to ensure that VMs stagger updates and have varied power and network connectivity, preventing you from losing all your VMs with a single network or power failure. Availability sets perform its task by grouping VMs in two ways: update domain and fault domain. Update domain. The update domain groups VMs that can be rebooted at the same time. This allows you to apply updates while knowing that only one update domain grouping will be offline at a time. All of the machines in one update domain will be updated. An update group going through the update process is given a 30-minute time to recover before maintenance on the next update domain starts. Fault domain. The fault domain groups your VMs by common power source and network switch. By default, an availability set will split your VMs across up to 3 fault domains. This helps protect against a physical power or networking failure by having VMs in different fault domains, thus being connected to different power and networking resources. Best of all, there's no additional cost for configuring an availability set. You only pay for the VM instances you create. Azure Virtual Desktop. Azure Virtual Desktop is another type of virtual machine. Azure Virtual Desktop is a desktop and application virtualization services that runs on the cloud. It enables you to use a cloud-hosted version of Windows from any location. Azure Virtual Desktop works across devices and operating systems and works with apps that you can use to access remote desktops or most modern browsers. Azure Virtual Desktop provides centralized security management for users' desktop with Azure Active Directory Azure AD. You can enable multi-factor authentication to secure user sign-ins. You can also secure access to data by assigning a granular role-based access controller RBAC to users. With Azure Virtual Desktop, the data and apps are separated from the local hardware. The actual desktop and apps are running in the cloud, meaning the risk of confidential data being left on a personal device is reduced. Additionally, user sessions are isolated in both single and multi-session environments. Containers. Containers are a virtualization environment, much like running multiple virtual machines on a single physical host. You can run multiple containers on a single physical or virtual host. Unlike virtual machines, you don't manage the operating system for a container. Virtual machines appear to be an instance of an operating system that you can connect to and manage. Containers are lightweight and designed to be created, scaled out, and stopped dynamically. It's possible to create and deploy virtual machines as application demand increases, but containers are a lighter weight, more agile method. Containers are designed to allow you to respond to changes on demand. With containers, you can quickly restart if there is a crash or hardware interruption. One of the most popular container engines is Docker, which is supported by Azure. If you want to run multiple instances of an application on a single host machine, containers are an excellent choice. Azure Container Instances. Azure Container Instances offer the fastest and simplest way to run a container in Azure without having to manage any virtual machines or adopt any additional services. Azure Container Instances are a platform as a service PaaS offering. Azure Container Instances allow you to upload your containers and then service will run the containers for you. Containers are often used to create solutions by using a microservice architecture. This architecture is where break solutions into smaller independent pieces. For example, you might split a website into a container hosting your front end, another hosting your back end, and a third for storage. This split allows you to separate points of your app into logical sections that can be maintained, scaled, or updated independently. Azure Functions. Azure Function is an event-driven serverless compute option that doesn't require maintaining virtual machines or containers. If you build an app using VMs or containers, those resources have to be running in order for your app to function. With Azure Functions, an event wakes the function, alleviating the need to keep resources provisioned when there are no events. On the other hand, Azure Function is nothing but a compute option which is event-driven and serverless, and it can be functioning without maintaining virtual machine or containers. Suppose an app is built by using the resources VMs or containers. Now, if you want to keep functioning the app, that resources VMs or containers have to be in running condition. Let's consider that scenario with Azure Functions. An event wakes the function and alleviating the need to keep resources provisioned when there are no events. To choose the Azure Functions will be ideal if you are only concerned about the code running your service and not about the underlying platform or infrastructure. Functions are commonly used when you need to perform work in response to an event, often via a REST request, timer, or message from another Azure service. and when that work can be completed quickly within seconds or less. Functions scale automatically based on demand, so they may be a good choice when demand is variable. Azure Functions runs your code when it's triggered and automatically deallocates resources when the function is finished. In this model, you are only charged for the CPU time used while your function runs. Functions can be either stateless or stateful. When they are stateless, the default, they behave as if they are restarted every time they respond to an event. When they are stateful, called durable functions, a context is passed through the function to track prior activity. Functions are a key component of serverless computing. They are also a general compute platform for running any type of code. If the needs of the developer's app change, you can deploy the project in an environment that is not serverless. This flexibility allows you to manage scaling, run on virtual networks, and even completely isolate the functions. Hosting options. If you need to host your application on Azure, you might initially turn to a virtual machine, VM, or containers. Both VMs and containers provide excellent hosting solutions. VMs give you maximum control of the hosting environment and allow you to configure it exactly how you want. VMs also may be the most familiar hosting method if you are new to the cloud. Containers, with the ability to isolate and individually manage different aspects of the hosting solution, can also be a robust and compelling option. Azure App Service. App Service enables you to build and host web apps, background jobs, mobile backends, and RESTful APIs in the programming language of your choice without managing infrastructure. It offers automatic scaling and high availability. App Service supports Windows and Linux. It enables automated deployments from GitHub, Azure DevOps, or any Git repo to support a continuous development model. Azure App Service is a robust hosting option that you can use to host your app in Azure. Azure App Service lets you focus on building and maintaining your app, and Azure focuses on keeping the environment up and running. Azure App Service is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. It supports multiple languages including .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python. It also supports both Windows and Linux environments. With App Service, you can host most common app service styles like web apps, API apps, web jobs, mobile apps. Web apps. App Service includes full support for hosting web apps by using ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, or Python. You can choose either Windows or Linux as the host operating system. API apps. A REST-based web APIs can be built by using the choice of language and framework, as like hosting a website into cloud. You get full Swagger support and the ability to package and publish your API in Azure Marketplace. The produced apps can be consumed from any HTTP or HTTP's based client. Web jobs. You can use the web jobs feature to run a program .exe, Java, PHP, Python, or Node.js, or script.cmd, .bat, PowerShell, or Bash in the same context as a web app, API app, or mobile app. They can be scheduled or run by a trigger. Web jobs are often used to run background tasks as part of your application logic. Mobile apps. Use the mobile apps feature of app service to quickly build a backend for iOS and Android apps. With just a few actions in the Azure portal, you can store mobile app data in a cloud-based SQL database. Authenticate customers against common social providers such as MSA, Google, Twitter, and Facebook. Send push notifications. Execute custom backend logic in C# or Node.js. Azure Virtual Networking. Azure Virtual Networks and virtual subnets enable Azure resources such as VMs, web apps, and databases to communicate with each other, with users on the internet, and with your on-premises client computers. You can think of an Azure network as an extension of your on-premises network with resources that link other Azure resources. Azure Virtual Networks provide the following key networking capabilities: isolation and segmentation, internet communications, communicate between Azure resources, communicate with an on-premises resources, route network traffic, filter network traffic, connect virtual networks. Azure Virtual Network supports both public and private endpoints to enable communication between external or internal resources with other internal resources. Isolation and segmentation. Azure Virtual Network allows you to create multiple isolated virtual networks. When you set up a virtual network, you define a private IP address space by using either public or private IP address ranges. The IP range only exists within the virtual network and is not internet routable. You can divide that IP address space into subnets and allocate part of the defined address space to each named subnet. Internet communications. You can enable incoming connections from the internet by assigning a public IP address to an Azure resource or putting the resource behind the public load balancer. Communicate between Azure resources. You will want to enable Azure resources to communicate securely with each other. You can do that in one of the two ways. Virtual networks can connect not only VMs but other Azure resources such as the app service environment for Power Apps, Azure Kubernetes service, and Azure Virtual Machine scale sets. Service endpoints can connect to other Azure resource types such as Azure SQL databases and storage accounts. This approach enables you to link multiple Azure resources to virtual networks to improve security and provide optimal routing between resources. Communicate with on-premises resources. Azure Virtual Networks enable you to link resources together in your on-premises environment and within your Azure subscription. In effect, you can create a network that spans both your local and cloud environments. There are three mechanisms for you to achieve this connectivity. Point-to-site virtual private network. Point-to-site virtual private network connections are from a computer site outside your organization back into your corporate network. In this case, The client computer initiates an encrypted VPN connection to connect to the Azure Virtual Network. Site-to-site virtual private networks link your on-premises VPN device or gateway to the Azure VPN Gateway in a virtual network. In effect, the devices in Azure can appear as being on the local network. The connection is encrypted and works over the internet. Azure ExpressRoute provides a dedicated private connectivity to Azure that doesn't travel over the internet. ExpressRoute is useful for environments where you need greater bandwidth and even higher levels of security. Route network traffic. By default, Azure routes traffic between subnets on any connected virtual networks, on-premises network, and the internet. You also can control routing and override those settings as follows. Route tables allow you to define rules about how traffic should be directed. You can create custom route tables that control how packets are routed between subnets. Border Gateway Protocol (BGP) works with Azure VPN gateways, Azure Route Server, or Azure ExpressRoute to propagate on-premises BGP routes to Azure Virtual Networks. Filter network traffic. Azure Virtual Networks enable you to filter traffic between subnets by using the following approaches. Network security groups are Azure resources that can contain multiple inbound and outbound security rules. You can define these rules to allow or block traffic based on factors such as source and destination IP address, port, and protocol. Network virtual appliances are specialized VMs that can be compared to a hardened network appliance. A network virtual appliance carries out a particular network function, such as running a firewall or performing wide area network optimization. Connect virtual networks. You can link virtual networks together by using virtual network peering. Peering allows two virtual networks to connect directly to each other. Network traffic between paired networks is private and travels on the Microsoft backbone network, never entering the public internet. Peering enables resources in each virtual network to communicate with each other. These virtual networks can be in separate regions, which allows you to create a global interconnected network through Azure. User-defined routes (UDR) allow you to control the routing tables between subnets within a virtual network or between virtual networks. This allows for greater control over network traffic flow. Azure Virtual Private Networks. A virtual private network VPN uses an encrypted tunnel within another network. VPNs are typically deployed to connect two or more trusted private networks to one another over an untrusted network, typically the public internet. Traffic is encrypted while traveling over the untrusted network to prevent eavesdropping or other attacks. VPNs can enable networks to safely and securely share sensitive information. VPN gateways. A VPN gateway is a type of virtual network gateway. Azure VPN gateway instances are deployed in a dedicated subnet of the virtual network and enable the following connectivity. Connect on-premises data centers to virtual networks through a site-to-site connection. Connect individual devices to virtual networks through a point-to-point site connection. Connect virtual networks to other virtual networks through a network-to-network connection. All data transfer is encrypted inside a private tunnel as it crosses the internet. You can deploy only one VPN gateway in each virtual network. However, you can use one gateway to connect to multiple locations, which includes other virtual networks or on-premises data centers. When you deploy a VPN gateway, you specify the VPN type, either policy-based or route-based. The main difference between these two types of VPNs is how traffic to be encrypted is specified. In Azure, both types of VPN gateways use a pre-shared key as the only method of authentication. Policy-based VPN gateways specify statistically the IP address of packets that should be encrypted through each tunnel. This type of device evaluates every data packet against those sets of IP address to choose the tunnel where that packet is going to be sent through. In route-based gateways, IPsec tunnels are modeled as a network interface or virtual tunnel interface. IP routing, either static routes or dynamic routing protocols, decides which one of these tunnel interfaces to use when sending each packet. Route-based VPNs are the preferred connection method for on-premises devices. They are more resilient to topology changes such as the creation of new subnets. Azure ExpressRoute. Azure ExpressRoute lets you extend your on-premises networks into the Microsoft Cloud over a private connection with the help of a connectivity provider. This connection is called an ExpressRoute circuit. With ExpressRoute, you can establish connections to Microsoft Cloud services such as Microsoft Azure and Microsoft 365. This allows you to connect offices, data centers, or other facilities to Microsoft Cloud. Each location would have its own ExpressRoute circuit. Connectivity can be from an any-to-any IP VPN network, a point-to-point Ethernet network, or a virtual cross-connection through a connectivity provider at a colocation facility. ExpressRoute connections don't go over the public internet. This allows ExpressRoute connections to offer more reliability, faster speeds, consistent latencies, and higher security than typical connections over the internet. Benefits of ExpressRoute. There are several benefits to using ExpressRoute as the connection service between Azure and on-premises networks. Connectivity to Microsoft Cloud services across all regions in the geopolitical region. Global connectivity to Microsoft services across all regions with the ExpressRoute global reach. Dynamic routing between your network and Microsoft via Border Gateway Protocol (BGP). Built-in redundancy in every peering locations for higher reliability. ExpressRoute enables direct access to the following services in all regions: Microsoft Office 365, Microsoft Dynamics 365, Azure Compute Services such as Azure Virtual Machines, Azure Cloud Services such as Azure Cosmos DB and Azure Storage. ExpressRoute supports 4 models that you can use to connect your on-premises network to the Microsoft Cloud. Cloud Exchange Colocation, point-to-point Ethernet connection, any-to-any connection directly from ExpressRoute sites. Colocation at Cloud Exchange. Colocation refers to your data center, office, or other facility being physically co-located at a cloud exchange such as an ISP. If your facility is co-located at a cloud exchange, you can request a virtual cross-connect to the Microsoft Cloud. Point-to-point Ethernet connection. Point-to-point Ethernet connection refers to using a point-to-point connection to connect your facility to the Microsoft Cloud. Any-to-any networks. With any-to-any connectivity, you can integrate your wide area network WAN with Azure by providing connections to your offices and data centers. Azure integrates with your WAN connection to provide a connection like you would have between your data center and any branch offices. Directly from ExpressRoute sites, you can connect directly into the Microsoft's global network at a peering location strategically distributed across the world. ExpressRoute Direct provides dual 100 Gbps, 10 Gbps connectivity, which supports active connectivity at scale. Azure DNS. Azure DNS is a hosting service for DNS domains that provides name resolution by using Microsoft Azure infrastructure. By hosting your domains in Azure, you can manage your DNS records using the same credentials, APIs, tools, and building as your other Azure services. Benefits of Azure DNS. Azure DNS leverages the scope and scale of Microsoft Azure to provide numerous benefits including reliability and performance, security, ease of use, customizable virtual networks, alias records. Reliability and performance. DNS domains in Azure DNS are hosted on Azure's global network of DNS name servers, providing resiliency and high availability. Azure DNS use anycast networking, so each DNS query is answered by the closest available DNS server to provide fast performance and high availability for your domain. Security. Azure DNS is based on Azure Resource Manager, which provides features such as Azure role-based access control to control who has access to specific actions for your organization, activity logs to monitor how a user in your organization modified a resources or to find an error when the troubleshooting, resource looking to lock a subscription, resource group or resource locking prevents other users in your organization from accidentally deleting or modifying critical resources. Ease of use. Azure DNS can manage DNS records for your Azure services and provide DNS for your external resources as well. Azure DNS is integrated in the Azure portal and uses the same credentials, support, contract, and billing as your other Azure services. Because Azure DNS is running on Azure, it means you can manage your domains and records with the Azure portal, Azure PowerShell, CMD alerts, and the cross-platform Azure CLI. Applications that require automated DNS management can integrate with the service by using the REST API and SDKs. Customizable virtual networks with private domains. Azure DNS also supports private DNS domains. This feature allows you to use your own custom domain names in your private virtual networks rather than being stuck with the Azure provided names. Alias records. Azure DNS also supports alias records sets. You can use an alias record set to refer to an Azure resource such as an Azure public IP address, an Azure Traffic Manager profile, or an Azure Content Delivery Network CDN endpoint. If the IP address of the underlying resource changes, the alias record as set seamlessly updates itself during DNS resolution. The alias record set points to the service instance, and the service instance is associated with IP address. At the last stage of this tutorial, I want to review the tutorial in terms of the following topics. Virtual machines. By means of virtual machine service, you can create and use VMs in the cloud. VMs provide infrastructure as a service IaaS in the form of a virtualized server and can be used in many ways. Virtual machine scale sets. In Azure, virtual machine scale sets is defined as a feature or tools where you can create and manage a group of identical load balanced VMs. Virtual machine availability sets. Virtual machine availability sets is defined as a tool by which you can build a more resilient, highly available environment. Azure Virtual Desktop. Azure Virtual Desktop is another type of virtual machine. Azure Virtual Desktop is a desktop and application virtualization service that runs on the cloud. Containers. Containers are a virtualization environment, much like running multiple virtual machines on a single physical host. You can run multiple containers on a single physical or virtual host. Azure Container Instances. Azure Container Instances offer the fastest and simplest way to run a container in Azure without having to manage any virtual machines or adopt any additional services. Azure Functions. Azure Functions is an event-driven serverless compute option that doesn't require maintaining virtual machines or containers. Azure Virtual Networking. Azure Virtual Networks and virtual subnets enable Azure resources such as VMs, web apps, and databases to communicate with each other with Azure users on the internet and with your on-premises client computers. Azure DNS. Azure DNS is a hosting service for DNS domains that provides name resolution by using Microsoft Azure infrastructure. Thank you for watching this tutorial. I hope you all have been able to take the idea about the Azure Compute and Networking services. If you think this tutorial is helpful for learning the Azure Cloud Computing, please click on the like button and request you all to share it more and more to the person who are searching the tutorial like this. If you have any questions on this tutorial, opinions and queries about this channel, please type this in the comment box. You also mail me. In the description box, email ID is given for you. Kindly subscribe this channel and click on the bell button so that you can get notification when new tutorial is published.